All right, let's talk about the shapes of different electron orbitals. Remember, electrons behave like a standing wave. We can't think of electrons as little balls. You have to think of them as a standing wave. So just like this string right here, when it's vibrated correctly, makes this weird shape. The string, when it's sitting still, it doesn't have that shape. Kind of like the electron is a particle, but because the electron is a standing wave, like it's sort of like kind of vibrating, it makes a shape. So the way we calculate that shape is from the wave function. Now, don't worry too much about this. You don't need to worry about the details. Just know that a wave function is a mathematical equation. We call it psi. That's the Greek letter psi. It's the mathematical equation that describes everything that we can know about an electron. Its position, its energy, and so forth. Okay, so the Schrodinger equation is really what we're talking about. It gives us the wave function for an electron. Okay, but don't worry about the details for how we get it or what it looks like. Here's a crazy example for a simple electron. It's very mathematically complex, not something that we need to worry about. The point is that if you take that wave function and you square it, you can plug in a position and you can figure out the probability of finding an electron at that position. So quantum mechanics is all about probabilities. So the electron doesn't necessarily move in straight lines. We don't know how it moves, but it does move. So you can calculate the probabilities and do it over and over again for a 1s electron, and you get this kind of shape. A high probability of finding it very close to the nucleus and a lower probability of finding it outside there. So what we get is kind of a spherical shape. And if we pick kind of an arbitrary cutoff point, say 95% of all the electron, we call it electron density, is within a certain radius, then we can show it as a sphere. And so we generally think of s orbitals as a sphere. So 1s orbital is just a single sphere. Now a 2s orbital has a node in between the inner sphere and another layer sphere. Remember, a node in a wave is this kind of thing here. It's a place where the wave is not, the amplitude is zero. Okay, so we have those kind of things for electron orbitals. We have a node in between when it's a 2s or a 3s. In a 3s orbital, there's 3 layers with a node in between each one. The important point to take away from this about s orbitals is that they have a spherical shape. Boom, that's really all you need to remember about s orbitals for now. Okay, if we do the same thing for p orbitals, we use that wave function to figure out the probability. 2p orbital looks like that. It's got 2 lobes with a node, a nodal plane in between. So this is one 2p orbital. Can hold 2 electrons, but it's not like one electron is here and one electron is there. Both electrons are somewhere in that area. That's the shape the wave function makes. So a 3p orbital would look like this. It has the same kind of shape, nodes, and then another kind of bigger layer onto it. But again, the take-home message for p orbitals is they have this kind of dumbbell shape. Sometimes it's shown like this, sometimes it's shown like that. Doesn't matter a lot. The point is that they have that dumbbell shape. So a complete 2p subshell, which has 3 p orbitals, will look like this. One p orbital in the y-axis, one p orbital in the x-axis, and the last p orbital in the z-axis. So they're all perpendicular to each other. Now, why are we worried about this? Because it shows us, we use these shapes to predict how electrons can interact with other atoms, i.e. chemical reactions. D orbitals are weirder. So a single d orbital has 4 lobes to it, and you get 4 different ones like that, and then the last d orbital is like this donut with a thing through it. Kind of weird. D orbitals, just look at that and kind of be familiar with it. We're not going to worry too much about d orbitals until next semester. The most important shapes to know right now are s and p orbitals. And then you can go beyond that. So again, these are mathematical calculations from the wave functions. So you can see L equals 1, that means an s orbital, right? So spherical, spherical with nodes, so you get more layers. L equals 1 is a p orbital, d, f, and a g orbital. So there's all sorts of weird stuff.